And I'm disappeared. When it in you.
We're good. We're good.
Oh my god.
Yeah, so going back to that, so we found a different way for rewriting the numbers we have, right? So let's see if we can, oh, wait, what? Okay. Let's see if we can, sorry, something in my Zoom just popped up. Let's see if we can find like some connections with what we have here. So we have 2 squared plus 3, right? So we're writing it as a power of 2 plus something. So if we have, we start on 1 here, we find that the winner is, we find that the winner is 7, right? So we have, we'll make another chart here. So we have 3 and 7, right? So this is the remainder. We'll call this something else. We'll call this like, we'll call this, so we can write it as, n. So we can rewrite the numbers here, n to the x, or sorry, 2 to the x plus a. Right, so x will be the power. In this case, x is 2, and then a. So we'll write this sort of here. So you can keep track of this. So let's move on. So we have 7 here. So we'll do the next one up. So we can also do the next one in our original list here. So that would be 8. We're not 8, 9. So if we do 9, 4, 5, 6.
We just did 9 like 3 seconds ago. We did 9 3 seconds ago.
All right, wait. Okay. What was the winner? I forgot. Oh my god. Sorry. I forgot. I'll just go do 9 again. So go cross this out. So 9 is 3, right? So the winner of 9 is 3. And if we rewrite 9 as a power of 2, 9 can be equal to 2 to the third plus 1. So we have 1 here.
Could we do 3 to the power of 3? That would make sense. I mean 3 to the power of 2.
Dude, 3 to the power of 2 would be different though.
No, but 3 times 3 equals 9.
Yeah, but we're trying to write it as a power of 2.
Oh yeah. Oh yeah, I forgot what we were thinking.
Okay, so let's do one more. We'll do 11, and then we can try to figure out a pattern from what we have there. So if we start on 1, we can go cross out 2.
Wait, what? Nobody's here. Dude, there's only 2 people.
You and Olivia are still here. I don't know about the other guy. David left because of battery on his device, so he'll be back.
Okay, but where's the other teacher?
Oh, it's David, but
Oh, I thought there were 2 people teaching.
yeah, it's gonna be me and David. David will be back though. Don't worry.
Oh, okay. Cause like, where's all the students? Like Leo.
It's like just us.
I know.
Oh, today's kind of weird. Yeah, it was.
It feels like a 1v1.
Yeah, it's a lot of bad luck, but yeah. So let's keep going. So we'll cross out 2, 3 will knock out 4, 5 goes 6, and then so on. So I'll just go do this real quick. 11 knocks out 1, 3 knocks out 5, 7 knocks out 9, 11 knocks out 3, and 7. So the winner here is 7, and then how can you write 11 in the pattern that we did before, right? You guys know? So the closest power of 2 we can get to this would be 2.
Oh, closest to power of 2, what?
Like we're trying to write this as a power of 2 to something, right? So 2 to the x plus a. So that's what we're trying to write this as.
Maybe 2 to the power of 2. That would be like 4 and then plus 3. Duh. Are we doing 7 or are we doing something
trying to get to 11 here?
Also to the power of 5.
What does, okay, on the plus and then the next number, what, no offense, but what is the number?
Which
11.
one? Sorry, yeah, my handwriting's really bad. Which one?
After the plus sign.
Oh, plus a. Yeah, that's a variable here. So this will change depending on each one. We're just trying to write into this form. I just wrote it like this. So 11, right, could be written as 2 to the third, which is 8, and then plus 3.
This feels like a 1v1 where there's like one teacher teaching one student.
Well, it's 2 and 1. So yeah, so we have a little pattern here, right? So what's the relationship between these? Guys, oh, this would be 2 times 3 plus 1. This would be 2 times 1 plus 1. This will also be 2 times 3 plus 1, right? You guys get that? So like the relationship between we found was a here, like our extra, adding on, and then the winner. Does that make sense, sort of? So we just did that. We tested this for, we did 7, we did 9, and we did 11. So we found here is that if you want to find the winner, it would just be writing here and then beat 2a plus 1. Makes sense. You guys get that?
Kinda.
Kinda. So you can see like we have 3 and then yeah. So moving on from this, so now we found a sort of rule, right? So we only did 3, but can we test this to figure it out for the rest of them? Right, so let me find a clean board here. We found that, so if we write the total number of people, right? Total number of people. We wrote that in the form.
If you want to write smaller, couldn't you just say total number, the sign of number, and then of a little stick human? Couldn't you just do that?
Yeah, I could do that. I don't really see that.
Or of PPL.
Oh yeah. I'm gonna stick to people. There you go. Total number of people. If we write it into the form of the power of 2.
Powder of 2. That sounds fun.
That's x. Power of 2 plus an extra. So we find that the winner tended to be
powder of 2.
yeah, like a power of 2. Like that's how I went.
Powder of 2.
Like 2 to the third is so 8. Like if you say 2 to the third equals 8.
Powder.
I said powder.
Yeah, I think you said powder.
Oh, okay. I had it messed up. Yeah, but if we wrote into this, we found that the winner tended to be 2a plus 1, right?
2a plus 1. What?
Yeah, so
What?
all right.
What?
Let's look at a list here of the winning.
Can we do 3 right now?
Oh, so the winner of 3, the winner of 3 is 3. But here, let's see if we can find that. So here we have the people, right? So on the left, you guys see the left, you see this chart?
Yeah.
So the number of soldiers in the winning position. Right? So we found that the total, if we can write the total number of people here as in this form, the winner would be equal to 2a plus 1. So we know that the powers of 2 will always be 1, right? So let's mark those out because those don't apply here.
Well, can we just do 3 and then let's just see if this technique works?
Yeah, so how can you write 3?
So, no, I mean like do the little thing and then when we, like 3 ends up to be 3, like 1 destroys 2, and then 3 destroys 1.
So the
Then
winner
3
would
ends up, but we know that how to make 3 is 1 to the power 2 to the power of 1 and then plus 1. So it's 2 to the power of 1 plus 1. 2
yeah.
to the
So
power.
if we wrote it like 3.
What?
So what would A be in this case? It would be 1, right?
Oh god, this does not make sense. But can we try 5? Because like 5 ends up
Yeah,
with
we can do a few more. So I want to make sure this all makes sense.
5 ends up with 3, but then like it does not make sense.
So how would
5,
you write 5 in this form?
2 to the power of 2 is 4.
And
And
then
4 plus 1 equals 5. So then that means 2 to the power of 1 plus 1. What?
oh yes, sorry if it's a little confusing, Olivia. But here, let's say we wrote it like this. So if we match it up to this form that we have up here, what would A equal?
What? It does not make sense.
I guess Kimi is confused too.
I don't know. Not the best at explaining, but let's get through this and then we can move on to a puzzle. Because I also have a puzzle prepared for the rest of class.
What about 3? What about 11? I think 11's never going to be working.
But let's figure out 5 first. We want to make sure you guys understand that. So in this case, A would be equal to 1, right?
What is 2 to the power of 5 equal 10?
No, remember 2 to the power of 5 equals 2 times 2 equals 5 2s multiplying together.
So what does that equal?
What
does that equal?
32. I think.
Oh.
To the 5th, not 2nd. But yeah, going back to this. So remember what we found earlier when we did these experiments, right? We tried to, oh, this is really messy. Here, let me clean this up.
11 does not make sense.
So what we did earlier was we found that we wrote 7, 9, and 11 in this form, right? So 7 would be 2 squared plus 3. 9 was 2 to the 3rd plus 1. And 11 was 2 to the 3rd plus 3. So what we found was that using the n part here, we found a pattern between this and then the winning number. So the winning number is always 2 times this plus 1. So that's going back to the rule we have here.
What if we have like 12? There's 9. So that means 9 times 2, which is 18. And then plus 1. 18 plus 1 does not equal the winning product. What does it mean?
Well, what do you mean? So 2a. 2a, so in this case, a is a variable, right? So here it would be 2 times 1 plus 1.
What do you mean by that? It's 12. 12, 2 to the power of 1, that's 2. 2 plus 1 equals 3. That's not equal to 9.
Oh, here. You mean up here?
I mean like in 9, the soldier part. If there's 12 soldiers and 9 of them are in the
so let's break 9 down.
No, I mean like 12.
Oh, you mean like 12 soldiers?
Yeah, and then 9 winning positions.
Okay, so 12 soldiers can be written as 2 to the 3rd plus 4, right? Does that all make sense? Because this is equal to 8. So 4 is equal to a here. So we do 2 times 4 plus 1. What do we get?
2 times 4, that's 8. Oh my god! Can we try
so that's
13?
Just a rough pattern. I don't know if I explained it the best.
Can we try 13? Because they did not give us the answer for 13.
Exactly. So we're going to try to figure out 13 here, right? Using the pattern that we found. So first of all, is 13 a power of 2?
I don't think so.
Yeah, it's not power of 2. So we know automatically it's not going to be 1, right? So now we have to use this one. So 13, what can we write it as? In terms of a power of 2 plus something. Oh, Olivia, wait, what grade are you in?
4th, almost 5th.
That's impressive. Okay. I thought you guys were all in middle school. Or my bad. But anyway, so yeah, we can write 13 as 2 to the 3rd, right? Because if we do 2 to the 4th, that'd be too big for this. We do 2 to the 3rd plus 5. So we have a equals 5 here. And we can do 2 times 5 plus 1, which gives us 11. So our winning position that we predict from what we found earlier through testing would be 11, right? So you guys want to test this? So this will be the final one before we move on to the puzzle.
Okay. And I think I'm even younger than Olivia. I'm in 3rd grade and I'm turning 4th. I'm even smaller than
You're in
you.
3rd grade. Oh my god. Okay, you guys are very smart. You're great.
Yeah. I was born with parents who both have PhDs.
What? PhDs? What do you mean by PhD?
It's like a degree you get for graduate school. Anyways, so moving back on, so we predicted that from what we found earlier, right? We predicted that if we have 13 soldiers, the winner would be soldier 11. So let's test this one really quick, and after this, we'll move on to today's puzzle because we always have one.
We don't have a today's puzzle, right? And David's not back.
Well, David will be back for the puzzle, so we're gonna go over that.
13. What?
That looks kind of like a lopsided circle.
It's a
Is
very
David
bad
back?
circle. Wait, let me fix that. Trying to get better at drawing circles.
Is that David? The connecting dude?
Who's? Eric? I don't know. Wait 1 second.
Could you unmute him?
I messaged him here. Anyways, let's go back to this. We're trying to make sure that what we found earlier is correct, right? So you have 13 people.
It's broken. It's a squished tire.
So okay, it's good enough for circles. So we start on 1. Let's go through, right? Just to
1 destroys 2. 3 destroys 4. And then all the even numbers. Yada, yada, yada. And
So we think
then 1
13?
destroys 3. Oh, wait.
13
Oh, yeah.
destroys 1, right?
And then 3 destroys 5. 7 destroys 9. 11 destroys 13.
13.
So you do find that it's 11, right?
Yeah.
Yeah, so it looks like the little guess we had here is right, correct. Yeah, I don't have enough.
So the winning position is 11.
Yeah, the winning position.
Wait a minute. It goes up by 2.
Oh, it goes up by 2 until we've hit the next power of 2, right? So
And then it
do
keeps
like
on
this.
going
Can we come up with a list now? Do we have a list for this?
Kinda.
Yeah, so let's try to add on to this list here. I'll make another blank slide here because it's getting sort of messy. So let's try to extend this list a little bit.
Oh, God, are you kidding me?
Yeah, from what we found, right? So what do we know so far? We know that we found a rule to figure out what it takes to find the winner.
Wait a minute. You said after we done 13, we could just go to the question problem.
No. Okay, this is the final part, I promise. But we got to put things together, right? So we found that if n is a power of 2, then it'll be 1, right? We already did some experiments to find that.
14 is not a power of 2, right?
14 is not a power of 2. So let's try to fill this out with what we know.
Oh my god.
15. Can we just do 2 more to 15?
Yeah, we're not gonna go very far. Don't worry.
Do you think I'm gonna spoil everything because I just noticed the pattern?
Oh, no, it's okay. Go ahead. Tell me what you think the pattern is.
So, okay,
14 is
first
gonna be
start-
13.
Okay, so have you noticed that it's like 1, 3, 5, 7, 9? It first starts at 1, then 1, 3, then 1, 3, 5, 7, and then 1, 3, 5, 7, 9.
And
Exactly.
then 1, 3, 5, 7, 9, 11, 13, and then 15, and then, yeah. I don't
Yeah,
know.
so what would 15 be if we keep on going?
15 would be 15.
And then what would 16 be?
17.
We can't have 17 winners. We can't have number 17 win, right? There's only 16 people.
Oh, no. That does not make sense.
So let's think back to 16. Is 16
Because
power
like
of 2?
15 plus 2 equals 17. And that's bigger.
You got to think back to the first rule we found. Is 16 a power of 2?
It is, I think.
Yeah, it's 2 to the 4th, right? 2 times 2 times 2 times 2.
Yeah.
So that goes back to 1.
And then 17, I think, is 17.
Oh no, we go back to 3 here, right? Remember.
Oh, yeah.
Yeah,
Three.
and
Figure this
eight-
out with the rule.
18 is 5, right?
Yeah, it should be 5. So now we
Yeah,
figured
we did it. Is David back?
David will be back soon now, should be.
Or maybe he'll be playing golf.
Why do you think he's playing golf?
He told me he's going to a golf park
Oh,
on Discord.
that's cool. All right, so we're gonna end with a fun logic puzzle. So let me share my screen again. So this one's called Jumping Julia. So this is a little bit.
Ooh, that's fun.
Yeah, so this is just mostly a logic puzzle. So we're gonna figure out some basic strategies to solve some of these. So first of all, I'll explain how
I
this
think
works.
the Zoom is gonna die again.
Oh, we should have enough time, don't worry. So so you're this rabbit, right? And if you're whatever square you're on, that's how many spaces you can move. So if you're on a square with 3 on it, you can move 3 spaces. And your goal is to get to the finish. So that explains the puzzle. So let's try to solve puzzle 1.
That's
Right.
easy. 1 to 3. 3 to 1.
You want to go to the right here?
Yeah, I want to go to the right.
And then
And then to the 3. I think I want to go to the 2.
you want to go to 2?
Yeah, and then no, I want to from now go to 2, and then I want to go to the goal.
The goal. There you go. You got it, right?
Yeah, could I go it any way more faster? Could I try going down to the 2? Could I go back and then try doing down to the 3?
Mhm.
Could I move down and then to the goal?
There you go.
That's faster.
All right, let's go to the next one. Olivia, do you want to give this one a try? Or?
Wait,
Yes.
is it the start one goes to the number 2 only?
Yeah, because you're
Can
on.
I do something? Could we get lost in this maze? And then could this be impossible?
Yeah, there's some.
I think it might be impossible.
Yeah, one second. Let me answer Olivia's question. So yeah, if you're on a block here, so on the start it says 1, right? So you can only move 1 space.
And couldn't just, but then couldn't you just scoop
Like,
in the middle path?
what do you mean 1 space?
Like if you're on here, you can move all the way to number 2. And if you're on 2, you can move 2 spaces, right? So you can move 1 and 2, and then you can make.
Does anybody play chess?
So you go on 2.
Which one? You want to go to the top one or the?
I think the top one.
Okay.
And then you have 2 moves left, right?
Yeah, you can move 2 moves. You can move 2 spaces because you're on the number 2 here.
I think
Okay,
we should go to 3.
you do okay, go to 3 and then back to the 3, like the 3 next to 2.
What do you mean? Oh, you have to move 2 spaces. So you can't like save it here.
Oh, okay, so 3.
So like here you can move all the way to the corner.
Okay, so go to the 3.
And then go down to goal.
Yeah.
All right, cool. So now we're just like, because these earlier puzzles are pretty simple, we can just go through and like just go with the
Oh,
flow.
can I try going down? Because I think if I go down, I might go into an infinite loop.
Oh wait, Is Eric saying something? Eric,
What?
you have your hand raised.
Yo, oh wait, I wanted to try the puzzle, but since you already did it, it's okay.
Eric has become the student. All right, well, we'll try some harder ones.
Can I try this one?
Wait, we're gonna go move on to 5 by 5.
Oh my god,
No,
that looks
9 by
so
9.
scary.
We don't have 9 by 9 this time. But yeah, so let's see if
Jonathan.
we can go with our earlier strategy of solving this.
Could we do a 9 by Z?
9 by what?
I think I got this one.
Could we do a 20 by Z?
No, Kimi, just let let's go through a few more of these before we.
Yeah, can you give me a chance? I think we should go to. Actually, just wait 1 second.
Wait,
Okay, yeah, I think we should go to the 2.
Can I ask a question?
Yeah, go ahead.
Can you move diagonally?
No, you can't move diagonally. You can only move in like a grid.
And then I think we should go to 4. And then finally, we can go back to 2.
This is the same pattern. Could we get something harder?
And now we can go to 2.
Eric.
And then now we can go to 4.
I think you're supposed to
And
go
finally go to the goal.
All right, you think you can do that in less moves?
Not really sure.
All right, so let's think of some better strategies we can do, because those few puzzles have been pretty simple. We can just go with the flow, right? So does anyone have like an idea of how we can work out this puzzle more logically instead of just like going?
No idea. This just looks like a disco dance.
Yeah, it sort of does. Kimi, do you have an idea?
No way. It's the first time I do not have an idea. Oh, I
What do
think
you
I
guys-
do. What if we step on 4
Step on
and
4.
then step
So,
on 1
like, what's your strategy of solving this?
and then step on 1?
Which one?
The right one, stepping toward the goal. And then step on the 3,
Oh, which one? Top or
next to the goal. And then we would go to the upper 3. And then to the right 3.
Oh, you can't go to the right 3. You have to
To the
move.
1.
Oh, you want to go to the
Whatever.
one?
And then to the 4,
Mm-hmm.
which will lead to the 1, which will lead to the 3,
Which
the
one?
bottom 3, to the right,
The.
to the right,
What do you mean the right? Like
I mean the left.
left 4?
Yeah.
And then now you're stuck. You have nowhere else to go.
All right. How about we try this like another way? Like instead of trying to go from the start to the goal, why don't we try to do it reversely? Like trying to go from the goal to the start.
Yeah, but the thing is not on the goal.
Yeah,
Yeah,
but then like just look at it. So from the goal, right? Like from which point can you go? Can you go to the goal?
Through the middle.
Like the
Well, just
What?
think about working backwards. So
yeah, working
like-
backwards. Yeah, like
Oh.
if you look at the top and the left, that's the only two way you could go, right? Right, Kimi?
Yeah.
But then if you look at the look at the left, there's basically no way you could go to the goal because the 3 here would not let you go to the goal. The ones will only go to 3.
Wait a second. But if I try to go from the goal to the start, and I just go from goal to 3 to 2
Yeah.
to 2 to 1, that doesn't work. So you
No,
can't just
like
do it in
you first
reverse,
go,
right?
you first go to go from the goal to 3, right? And then
Mhm.
after you go to 3, you could go to the 3 on the further left.
I think I found it. I think
And
I
then
found
you
the
could go
way.
to and then you could go to 1.
I think I found the
And then
way.
you could go back to 1. See, that's how helpful like going in a reverse order is, because then you could eliminate more choices, and that's why like sometimes instead of like going to the goal directly, you could try going backwards.
Oh, so you go to 1 and then to 3 and then to 3 and then yeah.
Yeah. Jonathan, can you like demonstrate it?
Yeah, so we go to here, then we move to 3, and move to 3, and then straight to the goal.
It's still kind of easy, not to lie.
Yeah, so by working backwards, we can avoid a lot of the guesswork. So let's try tackling a slightly harder question.
Yay, 45!
Oh wait, there's a timer that says 7:57.
Yeah, don't worry about that. We'll end pretty soon. We won't go.
Yeah.
It says 32.
All right, guys. So let's try to work backwards on this one again. So we know the goal's here, right? So let's try working backwards to get to the beginning.
Looks like David's back.
Yeah, so
Okay.
you guys know where we can go from?
So basically, looking at the
4.
work. Yeah. Go to the 4.
This one, right? Oh, you can't really see that here. Let me change the color.
Wait, can we go down to 4?
All right, wait 1 second. I'll just add. I'll add a notes here. So we can go to here, right?
No, I want to go to 2. Can I go to 2?
Oh, this one? This one here wouldn't quite work because if you.
No, I want to go to the 2 that the bunny can jump to.
Oh no, but we're gonna try to work backwards, so we don't have to.
Oh, I hate working backwards.
So we can come up with a faster solution. It's often more fun to just like go and see where it takes you, but this is the most efficient way.
Yeah.
So if we're done with the puzzle, our main priority is to go to the 4, like on the right, and then to the goal.
What do you mean?
Like so if you're working backwards, and so it's kind of like our goal is to go to the. So if we're not working backwards, our goal is to go to the 4, then to the goal.
Yeah.
This is not making
So let's think. So we know that the only way to get to the goal would be to go to the 4, right? Because none of these other options would allow us to get there. So now you think, how
And
do
then looking at the 4, like to just look at the top, the left, and then the bottom. Like
the
you're
2
not going.
jumps to the 4. The 2 can jump to the 4.
Yeah.
Which 2? This one?
So
The 2 that makes sense.
Oh, you mean this 2? That's
Yeah.
like the gray one?
The gray one, yeah. The gray
Yeah, so
one
the
can
2
jump
would
to
allow
the
us to
4.
jump to the 4. Now I can think back again. What would allow us to get to the 2?
I think
The 3.
a 3, but there's actually no 3 that can possibly get there.
No, the 3 on D5, I think.
yeah.
Eric
on the bottom.
got it.
Oh, what? Oh, I see. I was forgetting about the 3. I thought it was the 3 on B2. And then maybe from the 1.
Which one? There's 3 ones here. See on the top, the right, and the bottom.
I think
So you
it's
gotta
on
pick
the
one.
right. I think we have to go to the right.
And try the right one? All right.
I think we should go to the 2
Eric, why do you think we should go to the 2?
because if you think about it, it's the special choice, and the special choice, like the choice that is different from all of the other ones. Like if you're guessing on the SAT, then you would guess 2.
Okay, that makes sense.
Sure.
Wait. What if you go to the 4, then when you go to the 2, like, okay, never mind.
I think we're in an infinite loop. Sorry, but I think we're in an infinite loop.
Yeah. Well, Eric, even though the 2 is special, you're wrong in fact, because then you can go to nowhere with 2. So I'm sorry, Eric. You're incorrect. And then let's try what Wakimi soon. If we go to 1, actually, there's also no way to go, because then
So
see
could
like
we go
2.
to 4?
No, that would be like the 4 has to be. Oh wait, yeah. Never mind.
So our only options here would be the ones, right?
Yeah.
So let's see which one works. So let's assume,
They seem like the easiest.
yeah, so let's assume we do this one, the gray one. Where can we go from there?
Ooh, this is fun. What is on the side?
Oh, that's just the notes. So that just allows us to put some arrows in there. So
we
let's,
can cheat. Something tells me that we could cheat this.
could find better ways of doing it. I wouldn't call it cheating, unless you're just like looking at the answer.
Something tells me that if we hit the goal a billion times, something will happen.
But you can try
Right,
it after class. This will be on there.
well, let's stay on topic. Like if we stay on one, like where can we go, Kimmy?
Yeah. If we stay in this gray one, where can we go? How would we get to this gray one?
We could do from the 4, probably.
Which 4?
The right 4, where the bunny can hop to.
Well, if we hop
There's a lot of
here,
rapport.
if we hop to the A4, like the one where Bonnie can go to, there's not enough spaces.
Yeah.
Oh yeah, I see. I was counting wrong.
So do you see a different one?
I don't actually see much opportunity.
You could go to 2, right? The yellow 2.
True, but like then we'd be in possibly an infinite loop. Cause like then we go to 3, and then 3 would jump to 5, and if 5 would jump to 4, and then yeah, I'm not
Uh,
sure what we're gonna do.
If
If you
only
go-
the 4 was a 3.
Well, if you got to the like,
if you got to the like the yellow 2 on the second row, you'll be able to go to the 2 on the first row. If you go to the 2 on the first row,
I think
you'll
I
be able
got
to
a
get to
better
the 3.
idea.
And then you'll be able to get to
Just
3.
hop to the 4 and then hop to the goal. Done.
No, when you get to the 2 on the first row, you'll be able to get to 3, which actually completes the circulation.
Wait a minute, could we go to the 2, the top, the bottom? Wait, could well, if we're like on the yellow 2, that's a D2, the D2 the D2 something like that. That one. What if we jump to the 4? The 4 could jump to the goal because it's like 1, 2, 3, and then 4.
well, let's try the ones that we've already marked out, right? So we go to the 2 here, right? That wouldn't allow us to get down here. So the only way from this one, there'd be no possible ways from this one. So you have to try a different one, right?
It's impossible, I think.
All right, we know. Let me big brain this. I'm gonna speed run.
How do you what? So the time's running out in less than a minute.
That's why it's a speed run.
Oh, I get it. I get it.
It's all according to plan.
This is hard.
I don't think he's speed running.
I'm going actually.